Hello, everyone. Let's wait some minute for. Hello, everyone. Today we are going to talk about the benefits of including financial analysis in your PV system designs. Today I'm going to be presenting this webinar on my own. For those who don't know me, I'm Bernardino Martín. I'm the product owner of the generation area of pvDesign. I just started this new role. I come from the customer success team, so my main task now are to define the new requirements for the new functionalities of pvDesign and maintain the backlog. Today we are going to summarize first the project life cycle of a PV plant, and we'll check all the necessary agreements in project finance. And then we will see what outputs pvDesigns offer and how they can be used to create an early stage financial model. In fact, we will see a practical example with a demo project in pvDesign and an Excel file. And finally, at the end of the presentation, we will have a Q&A session. So feel free to write questions during the presentation so we can solve them at the end. Before we start, I want to announce Pulse. So Pulse is an event. It's a global renewables energy transition event that is organized by RatedPower, where you can join us to meet other PV industry pros like you in a unique event on April in Madrid. Okay, let's start now with the webinar, project life cycle and agreements. Okay, the typical PV project power plant generation development may take anywhere from 3 to 15 years, okay? And we can divide this timeline in different phases, okay? So first, we will have to carry out first you will have to carry out sorry okay yeah first you will have to carry out all the economic studies and technical studies such as pre-feasibility and feasibility studies to prove the technical and economic viability of the project. We will need also to do a site identification concept first, of course. Then we will have to negotiate and conclude all the necessary agreements, such as the power purchase agreement or PPA, to sell the energy that we generate. We will need also to sign some contracts with an EPC for building the PV plant. Also some operation and maintenance contracts with an O&M company. Also with the grid operator and so on. Then we will have to obtain all the necessary permits to connect the grid to the PV plant to the grid, and also acquire the land to build the project. Next, once we have all the agreements, we will have to negotiate with banks and investors to secure financing for the project. And when the financing agreements are executed, we will be ready to begin with the construction. This stage, when we finish, when we raise the debt and so on, is known as financial close. So we will have enough money available to draw down to fund the construction. Okay, now we have the construction stage. This may take between 1 or several years. And in this stage, we will build the power plant using the funds, okay, the debt and equity. And finally, once we have completed the construction, we will reach the commercial operation date, or COD, and this is when the PV plant operation starts. It's important to understand all these steps that we have seen in detail in order to be able to model all the project company cash flows, income statements, balance sheets, and so on. Okay, let's suppose that we are some developers, or a big utility, or a company that want to develop a solar PV project or to invest in a project and raise financing using the project finance method. To do so, we will have to set up a special purpose vehicle, or an SPV, for the project. So this is like a separate entity with limited liability for the project. So basically, this will be like a completely company from the developer. So this SPV will be ring-fenced. What means ring-fenced? Ring-fenced means that this company will have its own board of directors, own bank accounts, own financing reports, accounting, and so on. Okay, and if something goes wrong with the project company, it will not affect the sponsor or the developer. Okay. The SPV will raise debt from the banks and equity from the developer, from the sponsor. So we will receive money from both. Usually, this proportion is around 80 or 70% of debt of a loan, and the rest is equity. And also, it's important here that as we said before, this project company is an SPV, so it's a limited liability company. It will, if things goes wrong and the SPV goes bankrupt, the bank cannot go after the sponsor for asking for money, okay, because it's like an independent company. So that's why it's really important to model the cash flows of this project company before we ask for debt. Once we will have all this financing, debt and equity financing, the money will go to the PC contractor, who will be the asset under the PC contract. So once the asset or the PV plant is built and connected to the grid, we will sell so the project company will sell the energy to an off-taker or energy buyer, that is an external company, and this cash that is generated through this PPA agreement will secure a long-term revenue stream for the project company. With all this cash, we'll be able to pay the maintenance of the PV plant to the O&M service provider. And once all these OPEX costs are paid, we will repay the debt and the principal of the debt and the interest. And if we have some remaining cash, we will we will give money to the developer or the sponsors. Okay, so here we have a resume table. So we can see that the project finance, the collateral value is very limited. So the financing, the project finance is based on the cash flows that the project company can generate. Okay, so the lenders will look really close to the cash flows of the company in order to see the amount of money that they can lend to the project company, and to see if they are able to pay the principal and the interests. So to do so, we will need to do some probabilistic studies of the energy yield, calculating for example, the P95 or P90 to estimate how much cash can be generated in the worst case scenario, and to see if we are able to, so if the project company is able to repay the debt and the interest. That's why we can use some of the outputs of pvDesign to create a model, a financial model, to evaluate this debt. Okay, to do so, we are going to go to pvDesign and to check some of the documents that can be used. For example, for the energy estimation, let me exit. For the energy estimation, here we can see in pvDesign, I did this project just to check some of the documents. For example, we can go here in documents and check the energy yield report. In this report, here we will see the logo of the company. This report can be shared or can be used to share it with the bank to see basically the energy yield that the PV plant is going to generate. First, we have an introduction where we have the total resource, a small picture of the layout, where it's located, some information about the areas, the slopes, and so on. And then let me go to the bottom. Here we have some information about the equipment. And here in the bottom, we have a resume table about so we have an explanation of the different losses of the PV plant. And this losses, this is like the total loss in a yearly basis, but they are also calculated in hourly. So we will see that later now in the Excel file. And here we can see this table is like a resume table with all the losses or gains, depending on the sign of the PV plant. Okay. So here we can see the P50 estimation, and also if we use the the probabilistic yield estimation tool from pvDesign, we will get also the P99 or P95 estimation. This means P99 means that the 99% of the years we are going to generate more than this energy. So this information can be used to model the cash flows in the worst case scenario. Let me go also download the Excel file. So here we have the energy results in Excel. Okay, this is also an example of a financial model that we are going to use later to see how can we use the data. Okay, this file, this energy report, is generated by pvDesign, and here we can see the early production data. Okay, we have also the nighttime consumption. This is important because we are going to generate energy, but we are also going to consume some energy during the nights, and this have to be discounted from the PPA agreement, or it will depend, I think, on the case. We also have here some tables where we can see the injection per hour and per month, so we can also calculate maybe if we have a monthly analysis or quarterly analysis, we can add all this data and to get the production. By the way, we consider here in the early production the degradation of the module, so you don't need to consider it in your financial model if you're taking it directly from here. And for example, we can use these two tabs to go, for example, to our simplified model, this one here, where we have several inputs, several assumptions. And we can go, for example, to the energy tab here, and we can paste our energy production, energy generation values, okay? And these values can be used later to calculate all the cash flow and all the financial statements that we will see later, okay, here. Okay, going back here to the Excel, other file that is interesting is the bill of quantities and the CapEx. So especially for the EPC contractor, here we can easily, we can estimate the cost of the V plant using our CapEx tool, okay? I will show you how to create CapEx templates, but basically here we have the CapEx templates, and we have some CapEx from Arena. So we have a database from Arena, and these costs are based on the big power. Okay, there are simple templates. For example, this one of Arena is based on the big power always, but we can create more complex templates if we are EPCs to calculate the total cost of the B plant in detail. So let me use this one, for example, here. This CapEx template is empty, so we have no prices, but it's based, we can see on the different equipment from the B plant. So it's based on the bill of quantities. So if we know the prices for each module, we can set here this price also for the structures or the boxes, power stations, inverters, earthworks like cut and fill, fence area, foundations, all the trenches and cables. So we can give a price to each element of the P plant, and in that way we can calculate. We have a really accurate estimation of the capex of the P plant. Once we have this we generate the design with this template. Let me show you the result of the design. Okay, here I did an example taking into account. So we generate the bill of quantities. That is the base for the financial analysis or the capex sheet. And here in this capex Excel, we can see the details of the capex, how it's calculated. We can also get this value, okay? We can copy this value and use this as a capex for the financial model. So here we can go to capex, and here we have the total value. And this total value is the one that is going to be used to estimate the total debt that we need to get from the bank and the equity investors. And once we have these two values, we can also have an OPEX temp tab, for example, and we define some hourly prices as we have an hourly energy model. And with all these inputs, we can, for example, generate this financial model with some results. Here we can see, for example, some plots to see the OPEX, the scheduled principal repayments. Then the tax payments are done at the end because we're having an accelerated depreciation in this example. But yeah, all this information can be used for building a financial model. Okay, we have also here the financial statements with the revenue, the OPEX, the EBITDA. Then we can use also this EBITDA. If we have the working capital, we can calculate the cash flows. In this case, we assume that everything is paid instantly and the money is received instantly. So we are not having some working capital here. So basically, all this cash is the same one. And then also, yeah, you can pay taxes. In this case, we're not paying taxes the first year. We have in the tax expense here, but we are not paying the taxes because we are having the accelerated depreciation, as we said before. But yeah, this is just an example of a model, but you can build your own model taking into account the outputs from pvDesign, okay? Other interesting outputs from pvDesign are the reports, for example, for the interconnection facility. If we want to be connected to the grid with the grid operator, we can share some reports like this one here, the headline report or the interconnection facility report. We also have all the layout from the substation and from the overhead lines. So here we have some explanation of the location, and some information that can be shared with the authorities. Okay, so that's it mainly. Let me check your questions. What have you asked here in the chat? Okay. Let me see if I can see your questions. Okay, here we have a question where they are asking, how does the energy production account for land validations? Okay, I'm not sure if I understand your question. What do you mean by land validation? But basically, let me explain you how the energy model works, more or less. Here we have the layout, okay? So based on this layout, we have, for example, different pitch distance between structures. We have different groups, different DCC ratios. So we have all the electrical connection of the PV plant. So taking this geometry of the PV plant and the metadata from as an input also here from the PV plant. So taking into account this metadata from the area, you can also upload your own metadata, okay? If you have other sources. So using these two values, these two inputs, mainly we simulate the yield of the PV plant, and this yield is calculated using this energy yield methodology. So here you can check, you can read it in detail to see how things are calculated. Okay, so here you have the table of contents. This link is accessible for everyone, so you just need to look in Google for energy yield methodology, knowledge base, and you will be able to read it, okay? Is the tool available for download? No, currently our software is a cloud-based software, so everything that you do is online. Okay, so you can generate different designs, clone them, and everything is done on the cloud. So yeah, our focus is so we are based on the cloud because we want to run simulations fast. As you can see here, for example, I will like to change the pitch distance of this example. Let's say I want to reduce this to 4 meters. Okay, the GCR. I can refresh the layout in just just a few seconds. I can generate a new version of the design, and in less than 1 minute, I will have access to the new documents that have been generated, including all the AutoCAD files, the reports, and so on. Is the financial model integrated with pvDesign, or is it a separate product offered by RatedPower? Okay, so currently we have only a CapEx estimation tool. It's not a proper financial model as the one as I show in here. This is like a prototype that we did internally to evaluate if we include it in the future inside the tool directly. But for now, it's not available. We have just this model as a prototype internally, and we may develop it in the future and include it in the software. But now our software is more focused on the engineering part. So we are basically improving our documentation. We are also integrating energy storage. So our software developers are more focused on the engineering part. But maybe in the future we will develop also this financial model internally. Okay. I wonder how pvDesign user can get the financial model. Okay, so this financial model is a really simple one that we did. As I was saying, is private, it's internal, but you can, I'm sure that you can buy some of them on the internet or yeah, there are some special, like some people specialized on doing models for specific projects because this is a really general one. But yeah, maybe in the future we will be able to share it with you, hopefully, especially if you are a client. So let's see. Okay, let me see if there are more questions here. Okay, I think that's it. Thank you everyone for coming today. I don't know if you have more questions. When do you expect that pvDesign gives the functionality financial model? Okay, so I'm not sure when it's going to be available. To be honest, as I said before, we are focused now on more on the engineering part. Also, if you want to check, for example, just to show you here what we do now, we call it financial analysis, this file, but it's basically the capex, and it's based on the bill of quantities. So I can show you also the bill of quantities. And here in the bill of quantities, you can see all the details. Yeah, here we can see all the details like the amount of modules, structures with different lengths, structure lengths, inverters, power stations, and so on. Cables, also the substation bill of quantities, the energy storage bill of quantities also, and the overhead line. Okay, so that's it. Thank you very much, everyone. Thank you for coming today. I hope that you have enjoyed the presentation. and see you soon.